All right, welcome back, class. So today will be 8.4b, solving radical equations, day 2. More of the same. It'll just be extra practice for solving these radical equations. Reminder at the beginning, we still would like to check for extraneous solutions, and we're isolating x. So we need to do those inverse operations. So let's just do a little review. If we have the square root of x, we can rewrite that as x to the half power because my index is 2 and I have an exponent of 1. That's why then, to simplify it, we want it x to the first power. My inverse operation is to square it. Because now, when I do power to a power, you multiply, so that's x to the 2 over 2 power, which will simplify to just x to the first. So that's how those inverse operations work and why we can use them. So example 1, we're going to divide both sides by 2. That's my first step. Then we have x to the 3/2 power equals 125. I'm going to rewrite this as my root. So my index is 2. So then it's the square root of x cubed equals 125. So my inverse operation of cubing is the cubed root. So the square root of x equals, we want 3 factors. 125 is 5 cubed. Then the inverse operation of square root is to square both sides. So then we have x equals 5 squared, which is 25. Let's check for extraneous solutions. If we plugged in 25, there is no negative restriction. It would be the square root. 5 cubed is 125 times 2 is 250. So that works. You must check at the end to see if there is an extraneous solution. So isolate the root and x. So subtract 2 to both sides. We have 4x minus 7 equals 3. The inverse operation would be to square both sides. So 4x minus 7 equals 9. Isolate x. So 4x equals 16. Divide by 4. Therefore, x equals 4. Let's check it. So we would have 4 times 4 is 16, minus 7 is 9. The square root of 9 is 3, plus 2 is 5. Good. So that is a real solution. We want to get the roots isolated, so we're going to add 2 square roots of x to both sides. So now we have the square root of 3x plus 2 equals 2 square roots of x. We did an example like this yesterday. Inverse operation is to square both sides. When you square the left side, square root, squared, those are inverses. So that simplifies to just 3x plus 2 equals, we must distribute to each product or term here. So 2 squared is 4. The square root of x squared, that simplifies to just x, so 4 times x, which we can rewrite as 4x. So isolate x, get it all on one side. I'm going to bring the 3x to the right, so 2 equals, it'd be just x. So let's plug it in. Let's check to make sure 2 for x, substituting that it is a real solution. So we have the square root of 3 times, it'd be 3 times 2 is 6 plus 2 minus 2 square roots of x. So we cannot add or subtract our terms because they are not like yet. And that all equals 0. So square root of 8 minus 2 square roots of x. It's the square root, so we're looking for factors of 2. So let's factor this. Okay, so we have 2 here. So that becomes 2 when we factor it out. And what's left is a factor of 2 minus 2 square roots of x. Oops. And then now I suppose I could substitute in for x over here, which was 2. Now our terms are the exact same and our coefficients are the same. And in the equation it said equals 0. So when we subtract 2 squared is 2 minus 2 squared is 2, is that 0? Yes. So 2 is a real solution. Finally, one more here. So we have the root on one side, so we do that opposite or inverse operation. If it's a square root, we square both sides. 8x plus 1. Reminder, we are not distributing here like so because that is not a property. We must expand x plus 2 squared to x plus 2 times x plus 2. That's what squaring is. If we have 5 squared, that is the same as 5 times 5. So we must expand x plus 2 to x plus 2 squared and expand it. Next, we must distribute. So 8x plus 1 equals x squared plus 2x plus 2x plus 4 when expanded. Now we can combine like terms. 2x plus 2x is 4x. Again, we have this quadratic, this trinomial, so we want to set it equal to 0. My leading coefficient here for my greatest degree is already positive. So I'm going to bring the stuff on the left over to the right. I'm going to leave x squared where it is. So we must subtract 8x. So x squared plus negative 4x plus 4. And that equals 1. So we must subtract 1 from both sides. So subtract 1, subtract 1. So up here we have x squared minus 4x plus 3. And then if we do our AC method, A times C equals B, we're looking for something that multiplies to 3 and adds up to negative 4. So the signs will be the same because it's a positive, and we know they must be negative because they add up to a negative. So negative 3 and negative 1, does that multiply to 3? Yes. Does it add up to negative 4? Yes. So 0 equals x minus 3 and x minus 1. We can set both of those equal to 0 and solve. So x equals 3 and x equals 1. Again, one last step. We must substitute these values back in and check for extraneous solutions. So let's check for, actually, let's do 1 first. So I'm saying we're substituting 1 in. My colon is implying that I'm going to substitute it. So the square root of 8, when we plug in x, it'd be 8 times 1 plus 1 equals 1 plus 2. So the square root of 9 equals 3. 3 equals 3. Yes, that's good. So 1 is a real solution. Let's check for 3. So plug it in, we get 8 times 3 plus 1 equals 3 plus 2. So we're hoping it equals 5. So let's simplify. 8 times 3 is 24, and we still have plus 1, so the square root of 25 equals 5. 5 equals 5. Yep. So we just verified that both are real solutions, so there are no extraneous solutions. So those are the steps we're going to want to take when solving roots. Use opposite operations to isolate the variable. Raise each side of the equation to the same power. You must do the same to the left and to the right. And check for extraneous solutions. All right, again, thanks for watching. Let me know if you have any questions, and I'll see you later. Bye.